Good evening, everybody. Today I'm here with Merve. She is a machine learning advocate engineer at Face, and I'm pretty sure a lot of people know her already for her extraordinary developer advocate job at Face. But Merve will also be a speaker at our conference coming up on March 16th in Pavia at Pi4AI. So Merve, it's a pleasure to have you here. Welcome.
Thank you. Very happy. Thanks for the invitation.
Thank you for accepting. So let's get started. Can you tell us a bit more about your job? We haven't had a lot of machine learning advocates, so we would love to get to know more about you.
So at Hugging Face, we have very less strict job descriptions, and because of that, everyone can choose to do whatever they want. And in my job, I would rather do documentation, come up with ideas like applied machine learning ideas about the cutting edge models, give talks sometimes. And I think that's pretty much it. Like I build, I document, I talk about it, and have fun in the process. It's a bit like artist type of job, where you do not have anyone telling you what you are doing, but you rather come up with whatever you want to do. And I would say half of the company is actually a machine learning hobbyist turned into full-time. And that's the good side of it.
Yeah, that's a great position to be in. I would say I'm pretty jealous. So you do consume a lot of research, right? As a consequence of this, are you really pretty close to the edge of the state of the art and what's being currently developed?
Yeah. I mean, I like to come up with ways. For instance, recently I combined two models, like state-of-the-art models. Like there is a model for zero-shot open vocabulary object detection, and then there is another model for segmentation. And then I recently combined them to make like zero-shot open vocabulary segmentation. I do stuff like this. It's pretty enjoyable, and currently I'm doing my master's thesis on pretty much foundation models and like how to shrink them as well, which you will learn a bit about in my talk in the conference.
Oh, this is so exciting. So since you just mentioned it, let's jump at it. What will you be talking about? And can you dig a bit more into the details of shrinking models? You mean by pruning parameters or just making smaller models?
For my thesis, it's about distilling them, but there is various ways you can just shrink models. Like you can use quantization, or there is various techniques to reduce inference time and also like reduce the model memory. You can also do pruning, but mostly I have done quantization using Optimum, which is like an open source library developed by Hugging Face. And for my talk, I will be mostly talking about transformers library, the state-of-the-art computer vision models, and fine-tuning them. I will show a bit of the transformers API for fine-tuning and inference, and I will show a bit around also foundation models, because these models are like very powerful and you can just use them out of the box, and it is just useful for machine learning developers, so to say, people who develop machine learning based applications without necessarily just diving deep into the model. And I think that's pretty much it for my talk.
I think it's kind of really dense, but I'm glad it would be so fruitful. So many people will have a lot to learn from it. So let's talk about computer vision. It's always been basically your thing, right?
Not really, actually. Like previously, before this job, I was working to build chatbots and natural language processing. Okay. And mostly stuff like text classification, text retrieval, but still working around transformers library, like state of the art, retrieval and classification and more. And then I would build chatbots based on text intent classification and entity recognition problem. And
it sounds fun, but why did you jump ship?
So it was like an interesting shift.
Okay.
Why did I jump? Good question. I don't know, computer vision felt more interesting to me after a while. And I still sometimes play around the LLM tools and stuff. So it's not really complete in my mind altogether. So as I said, like I jump between things, but mainly I work on LLMs and vision, and sometimes things in the intersection, like vision language models, for instance.
Okay, so there's still a lot of room for a very question that come to mind. The first one being, since you've been doing this shift, and there's been this huge craze about LLMs. How did in-part transformers, but also these huge foundational models for language change computer vision in the past year?
I would say like the first model, like transformers-based model called Vision Transformers by Google Brain, was actually developed based on the, attention is all you need paradigm that came from NLP. And then most of the developments were based on vision transformers. These models we used as like sort of like a front end, like in the neck part, to enhance the features and also to classify them. And then people were using convolution-based models in the back end of these pipelines, because these are like convolution-based models are still good for feature extraction, and they are like not that computationally expensive as well. And currently, the state-of-the-art models are often based on just convolutional backbones with the transformer-based front end. So most of the developments were around that. Other than that, there is this multimodal area, which started with, I would say, CLIP by OpenAI. And in this area, you have image encoder and then text encoder, and then you can train them using contrastive training to have like sort of text to image to text embeddings. And then you can do multimodal search with these. And the CLIP has opened a way for many, many applications. And as of now, many of the image, models that can understand both image and text, which is, for instance, Cosmos 2 by Microsoft, Fuyu by Adept, or Blip by Salesforce, all of them are nearly built around this paradigm. They often have an image encoder, a text encoder, and a text decoder for answering and captioning images. So sorry, it was a long answer, but I think it was a comprehensive one.
Definitely. But so how if you allow another technical question, how do these image plus text encoders work? So do they project embeddings in the same kind of vector space, or do they work differently? How do they process text and images and have them return something that is comprehensible by a neural network? They need to have the same number of dimensions, of course, to be processed as input, but how do these encoders ensure that you can take text and images and make them feel the same for a neural network?
My internet is a bit unstable, but let me try to answer. So essentially, imagine you have like a matrix of like images on one side and then text on the other side, and you have images matching with texts, and then you are trying to make the model predict the most matching image to text the best, meanwhile pushing away the others, and this is called contrastive training. Like the others should be like less likely to be predicted, meanwhile the true ones should be more likely to be predicted. And this is how these models are trained. Like this, the main thing is behind the training objective, and thus the loss, rather than model architecture. And these models are jointly trained. Yeah.
Okay, thank you. Very clear. You mentioned a couple of models such as Cosmos 2 and Blip. These are all proprietary models, right?
What does proprietary?
Oh, sorry, like closed source. Sorry.
No, not really. Like all of them, like all the models I have mentioned are actually released open source. I do not know about the licenses of all of these models. Some of them are open source, have open source license, and some of them are called open access. And the reason why is that like a model weight and the architecture can be released openly, but they might have non-commercial license. This might be because of the company's decision on, like to open source something in big companies are very hard and they need to jump hoops of bureaucracy. It can also be because like the data labeling company might have said, hey, you cannot release this like that. And thus some of the models might have non-commercial licenses, but still be released with open weights and architecture. And these are called open access models. I do not know exactly if these models are open source or open access, but they're definitely either one of them and not completely closed. They are just released.
Okay, because I use some other models such as like Lava, right? Or Lava 2, different iterations of Lava, and then there's I think Cog or something another. So I didn't know how up to I think it's called Cogviel. I don't remember the name.
Cogvielm.
Exactly.
Yeah, they are released open source as far as I know.
Okay, so do these like how do they compare? So the state of the art for these multimodal models is just visual editing, right? So say okay, remove the cat from the image, blur the background and stuff, right?
Yeah, I mean you can do a lot of stuff with these models, but I think I'm not sure if they're used for editing. I think for editing purposes, diffusion models are better. But for CogVLM and other things, you can converse with the model. Like you can ask questions to models saying, questions about the image that it inputs and get text outputs. And yeah.
And so say you are, I don't know, you can peek into the future 5 years from now, or if you look at 5 years from now from today's perspective, what things gets you most excited about AI in computer vision and visual? What kind of applications do you see for the future of computer vision and more images and generative art?
So I would say last year, last year there was this boom of ChatGPT and other things, and people sort of thought that scaling is the way, scaling the model architecture rather than the data coverage. But recently the trend is to find a scalable architecture, and not only scale the architecture but also scale the data set through synthetic data. And many of these models are actually used for synthetic data generation, and they can generate high quality synthetic data. For instance, like especially the zero-shot models. And this year's trend is just find a scalable model, find the synthetic data generator, and just pre-train a large thing and move on. And I find this quite exciting because then you can see that you are not bound to many of the labeling, the labeling limitations. And the main problem was data coverage, but many companies are overcoming that. For instance, Meta has released a segment anything model, and this was trained on SA1B data set. It has 1 billion masks inside. It's a very big data set, but like masks as in like segmentation masks without any indicator of what class it belongs to, sort of. Because it is like after a while you can have like automated curation. Like initially you have manual creation, and then you automate it, and then you combine two curations and train a model. I would say scaling the other architectures are definitely interesting, and overcoming the data limitations are very interesting. Other than that, I really am a fool for zero-shot models. Like there is Owl model by Google. It was initially released as OWLWIT, and then they scaled it, and they said it's OWL V2, and then there is segment anything model. I also really like Cosmos 2, which was released by Microsoft. It's a vision language model. But what makes it different is that it has grounding inside, and because of this, it hallucinates less by design. And yeah, I think these three models are really interesting, and like what comes after these models are also very cool.
Wow, that's very interesting. Like, it gives you like a clear shot of what's the state of research currently. I have another question about this area of research. So, I had a kind of a feeling when this came out. I was joking, saying that I don't know what data will ChatGPT, actually GPT-4, be trained on, but I'm sure that GPT-5 would be trained on synthetic data. But then again, somebody came and told me, it was still when ChatGPT 3 came out. I was wondering at first, and this guy came up and said, but how can you know that models can actually learn synthetic data? So 2 years have passed, and we found out that we can use synthetic data to train models. Do these models learn? Do they learn better? Does the fact that they learn mean that this synthetic data is human quality and can be considered to be as indistinguishable from human generated content?
I mean, when you give synthetic data, you still transfer the inductive biases that are within the model, right? And that might be a thing. Other than that, I think on most of the time, what you do is you still have this manually created data set, and then you have semi-manually created data set, and then you have automatically created data set, and you combine them rather than completely giving a synthetic data set, because keeping a human in the loop is just good for sanity check. And what else? I was going to say something, but then I forgot.
It just happens. It happens to me all the time.
And like for the models that are trained with, for instance, distillation and so on, like there was recently a depth anything model that was sort of like segment anything, but for depth. And it consisted of two models combined, and it had like a student model inside that was trained using these three combined type of data. They distort the data as well in order for model to learn even better, so that this like when you give a hard loss plus distorted data, the model doesn't converge as fast, for instance, and it can actually learn variant data sets, like data sets that are the model becomes less vulnerable to some like certain features and stuff. There should be, I think it's called, I do not know the term for it right now, but yeah, like
Okay.
it gets less biased, let's say. Yeah.
Wow. So are we actually learning how to reduce bias in our modeling? That's what you're saying?
Can you repeat your question? I couldn't hear,
Yes, sorry.
sorry.
Are we actually learning to train models with less bias, or finding ways
Yes,
to?
exactly. Less bias.
Wow. So and synthetic data can actually help us do that?
Yes. I mean,
Wow.
it's not necessarily synthetic data, but when you introduce like a harder loss function, and also when you introduce distortions to synthetic data, it helps with like the bias that can be caused by the synthetic data itself, because you are distorting the data set. Like there are techniques like mix up and introducing noise and so on.
But both in text and in images. So blurred images and what for text?
What I mean was for the images and not for text.
Okay.
I'm not sure what type of stuff are introduced for text though. Like I am not aware of the recent techniques in text.
Okay, thank you. So, I would say, so I had just two more questions. The first one being, suppose a young data scientist or somebody like in your position who didn't have this chance to be exposed to so many things, or just somebody who was just starting their studies and they're really fascinated by AI. What kind of advice would you give them, given today's world, right, for prosecuting a career in data science and machine learning, especially in the field they're working in?
Well, honestly, I also I'm not a beginner in the eyes of other people, but I consider myself always to be beginner because of the fact that like if you just get rid of your reputation, you can learn easier and have like a better learning curve. And also this area is always changing, so whatever you learn might not be used the other day. And I would suggest to get their hands dirty and read papers, check out the whatever's coming out. But there's also like high signal there is less signal to noise ratio these days around the machine learning research because everyone is doing that. And I would suggest them to maybe check out, there are some paper curators, like on Twitter, there's AK. Maybe like follow these type of people and try to see, prioritize the papers and the tools they are going to use, because it's very easy to be overwhelmed. And above that, also pick an area to work on and not work on like multiple stuff, because again, you can get very overwhelmed. And also for me, at least, it worked a lot that I tried to keep always like a rookie mindset in this, so that I do not stop learning, because it never ends. It's sometimes overwhelming, but I still find it very exciting to work at machine learning. So it's worth it, I would say.
That was super interesting. Thank you. The very last question is, as a closing thought, right? If you could have attendance to your talk, remember one thing from it, or if you could just give them one thing to take away, what would that be after they come out of your talk at a conference?
Good question. I think like I think the audience would just go and like what I often imagine is that, and it usually happens, is that after I give a talk, if the person has never interacted with these type of models, since we have a lot of nice abstractions over these models, they can just go and see that it's incredibly easy to use cutting edge machine learning models, and it doesn't require any there is like the barrier of entry to do that is very low. And I think the realization of that fact is just one thing people take away.
Oh, that was very interesting, but it props up another question. And how do you think, what kind of role is Hugging Face playing for you? It's basically the next GitHub, right? But it also doing an excellent job of abstracting away and kind of democratizing, giving everybody the tools to do this kind of thing. Do you think that is it offering access, like too broad of an access? Do you think, for example, what would be the foot guns of these Hugging Face libraries? For example, will they abstract too much away from the complexities of training a model, or hiding away the theory that you need to? Will they make you feel like, oh yes, but I can just do pip install transformers, but and make you feel like you don't need to study the theory?
I think it depends on what you are building. Like, people who started with ChatGPT are now more exposed to internals of many of the models, and also the math behind it. Just to use the open source models, I would say it just reduces barrier of entry, but once you build a product, and not only the minimum viable product, you need to know, my internet is very bad. You need to know the internals of the model sometimes. Like as you go through the, like for instance, when you build a product based on it, your needs become more specific, and thus you feel forced to learn the internals of these models. And I think that's when it becomes necessary. But if you are just building a MVP, you found a use case, and you need some money, and then you can have time and resources to actually work on this, that's when you start doing that. But it for sure reduces the barrier of entry.
Thank you. It was really enlightening. Okay, thank you. Everybody heard it. Okay, so thank you. It was very enlightening, Merve. I'm really glad to have you as our speaker at the conference. I can't wait to see you there, meet you in the flesh. It's going to be really exciting. Remember that anyone who doesn't have a ticket can watch the conference. Will be streamed online on YouTube. So it's a pleasure. I hope to see you soon, and thank you for the time for this interview.
Thank you.
Ciao Merve.
Ciao.
Thank you.
Thank you.
See you soon.
This is
Ciao.
the main organizer of the event, Alessandro.
See you soon.
No, everyone had a good job organizing this event. So Tao is our star in organizing the event. So thank you, Merve, for your
Thank you.
presence. Thank you for accepting our invitation to join us
Thank
at
you
the
so
conference.
much.
And we were waiting for you in our headquarters in Pavia. Okay. Thank you for your time.
Great.
Thank you very much.
Grazie.
Bye bye.
Ciao Merve, see
See
you.
you.
Thank you, Luca.
Ciao.
Thank
Oh,
you.
grazie.
Ciao.
Ciao.